Now let's move on to types of characteristics. Types of characteristics. We draw graph between current and voltage parameters. So we know that in the circuit, the parameters take an input side and that is input parameter, output side output parameters. So the transfer input characteristics, which indicates one parameter from input side, one parameter from output side. VGS is input side and ID is output side in the circuit. So only it is called as transfer input characteristics. Then comes drain characteristics. In drain characteristics, two parameters are taken at output side only. So only it is called as output characteristics. Now Scottlay's current equation is defined for FET as ID will be equal to IDSS or within bracket 1 minus VGS by VGS of means where the pinch off occurs, which will be taken as VP here. So once we take VP, substitute the values, and then VP gets cancelled. We have two cases of VGS equal to 0, VGS equal to VP. When VGS equal to 0, we have ID equal to IDSS. When VGS equal to VP, at saturation, VP gets cancelled, and then IDSS will be equal to 0. 1 minus 1 will be equal to 0 now. So let's see the graphs of it. This is the transfer characteristics. When VGS is VP, we have ID equal to 0. When VGS is maximum, we have maximum IDSS value. When VGS is 0, ID will be equal to IDSS in this formula. Okay, now let's move on to drain characteristics. So this is the drain characteristics. We see three regions here. This is the ohmic region, saturation region, and the breakdown region. Okay, now in the ohmic region, the relation between current and voltage will be linear. So it follows the Ohm's law. That is, variation in current and voltage will be in linear form. So only it is called as ohmic region. Once the values cross the green line, dotted green line here, the area is called as saturation region in the graph. So this graph is drawn between ID as well as VDS here. So both the parameters are output parameters here. Now once putting VGS constant 0 and making it still negative, the curve is moving towards the axis, x-axis here. And likewise the current will be, IDS will be constant here. ID will be equal to IDSS over here. Whatever change, it will be change in voltage, but the current in circuit will be same, constant. And now after that, if we still increase the VDS values, it enters into breakdown region, which is not a desired operation of FET. The device will get damaged here. This region is called as breakdown region. That is, small change in voltage leads to huge current here. Small change in voltage leads to huge current. And now let's see the JFET parameters. These are the four parameters. Drain resistance. Resistance means voltage by current, so it is called as drain resistance. Putting VGS constant. Then drain conductance, GD. Okay, and now it is 1 by RT. So VGS is made constant. Then drain conductance. Drain conductance means we know that conductance is taken as transfer conductance ID by VGS. So the parameters are output parameter and input parameter here. So transconductance. Similarly, we have mu, amplification factor, which is ratio between output voltage and input voltage. VDS is output voltage, VGS is input voltage in the circuit. Now let's see the next video on difference between JFET and BJT. Thank you for watching. Listen to the next lecture.